Have you ever wanted custom printed t-shirts, but didn't want to shell out the $12 to $20 to have one professionally made? Have you ever had a voice in your head that said, I could make that, when looking at industrially made products? Or a voice in your head in general? No? Just me? Should I stop what I'm doing and seek medical help to quiet these voices in my head? No. Today we're going on a little adventure that will cost way more than it would cost to have the t-shirt I want professionally printed, and one that will yield a significantly worse shirt. Today we're going to make a t-shirt printer. Now, to start, I wanted to make this device for as cheap as possible, with the idea that, theoretically, I could actually save money by making it and printing my own shirts instead of impulse buying custom t-shirts. I also knew I wanted to make a printer with inexpensive consumables, so that ruled out expensive inks or transfer paper. No, I wanted a device that could print in house paint. I figured this would be a good choice, as have you ever tried to get exterior house paint out of clothes? It's impossible. Next, for the frame, I searched around my room for any cheap supplies I had lying around, and found some PVC piping, which I know is strong, straight, and looks a lot like a linear rail to me. Armed with these two design choices, exterior house paint and PVC piping for the frame, it was time to start designing. So, I hopped into CAD and began designing a simple Cartesian CNC frame using PVC pipes and other 3D printed parts. The main idea was to have two parallel rails with a crossbar. The crossbar would slide along the two parallel rails, and then a printer head could slide along the crossbar, and voila! Seemed like a good idea at the time. After a few tests, I realized I wouldn't even need to make any rolling bearings, as the 3D prints were smooth enough to slide nicely along the PVC pipes. After a few iterations, I had a prototype which worked really nicely. Then, I realized I had a problem if I used PVC pipe for the crossbar. PVC piping, if you don't know, is round. Thus, maintaining a specific rotation about a singular crossbar made from PVC piping would be almost impossible unless I added some sort of stabilizing rod or something. For some reason I still cannot explain besides that I made this decision at 3:30 a.m., I decided this was a deal breaker. No way was I going to include another $1.43 length of pipe in this project. So I scrapped the entire design. Alright, you know how the last design was going to have a simple Cartesian frame? What if we made a new printer that used polar coordinates instead? And how does this solve the problem we ran into last time, you might ask? I would say stop asking such silly, nonsensical questions. So the main idea of this is to have some sort of turret that can rotate and have an arm on that turret that will go in and out and ta-da. Now we can do everything the Cartesian frame can do, but use more math to figure out how to get from point A to point B, and lose precision at farther radial distances due to the squared cube law, or we're 2D, so maybe it's the square law or whatever. Anyway, now that we have a good idea, let's start designing and printing and assembling. After about 3 hours of printing, I got cold feet, and then I had the brilliant idea. Why print when we can just cut? Alright, onto the third design now. Instead of printing all of the parts, I decided to design my contraption using plywood for the larger parts. In reality, I still printed just about everything, but this time I was convinced my idea would work. A few painful hours of CAD, a few excruciating hours of printing, and some janky cutting later, and wow, it's all starting to look pretty good. Also, for the extruder, I purchased some syringes and needles. My idea was to take the paint, put it in the syringe, and then push it out of the syringe through the needle onto the fabric. Very complex, I know. Additionally, I wanted to make the extrusion height, relative to this shirt, adjustable, with the end goal of making it auto-level itself so the needle is just off the surface of the fabric at all times. So, I designed a relatively complex mechanism using two motors to raise and lower the syringe, and also push on the syringe plunger. Now that we got the frame all squared away, I'm sure it's not going to take too long to get it all up and running. Now, onto the electrical side, I decided to use some of the tiny 28 BYJ-48 stepper motors I had lying around because I ordered them by accident, and now I need to justify my bipolar spending habits. I messed around for a while with the included stepper motor drivers, got frustrated, and resorted to using the cheap and standard A4988 stepper motor drivers. For the rotary motor and arm motor, I decided to use some tiny NEMA 17 motors I found on the side of the road, because free is free, and if I spend more on this project than 2 or 3 shirts equivalent, then what's the point of all my suffering? Now, just for some simple code that I completely stole from a previous project, and let's try it out. Alright, so that didn't work so well. I tried dialing in the stepper motor currents, tuning different parameters, speeds, accelerations, and tried replacing the original rotary and arm gears with smaller gears to produce more torque, but everything was just too jittery and shaky. Nothing worked at all. On the extruder side of things, not surprisingly, nothing worked at all. After a few more days of debugging, I got fed up with all the crappy 3D printed gears and all the problems that came along with them, all the skipping, jamming, etc. So I replaced the arm and rotary gears with belts and aluminum pulleys, and suddenly everything started working. Until this point, I wasn't even sure if my math was close to accurate, but I was able to print a somewhat acceptable image using this system. I still didn't have any bed leveling or measuring going on, but at this point, it was just time to finish the project. Now, for the moment we've all been waiting for, can it actually print a t-shirt? Yes, watch as this marvelous machine so gracefully, so elegantly, without any human input or attention, draws a beautiful image on a t-shirt. Upside down, of course, because of a typo in the code and a lack of time for testing. But anyways, look how, without any touch-up needed, this t-shirt looks so good. And if it was created so quickly, only 5 minutes of painfully slow, screaming stepper motors in any image, that is, any single color image that's not grayscale, can easily be converted into a stylish shirt. In actuality, this device works rather poorly, as I'm sure you've gathered. I want to revisit this project in the future, and I bet if I spend a little bit more money and design everything when I'm not sleep deprived, then it'll work out a lot better. I've learned a ton though, and next time I would implement a reciprocating printing head to reduce tearing or catching on the printing surface, as well as using a Cartesian frame for more rigidity and ease of use. Anyway, thanks for watching, I hope you enjoyed, and I'll see you next time.